So typically when we're interoperating with APIs, there comes a challenge of maybe the API is written in, I don't know, I'll say Java, for example. And typically Java and R don't manage data types in the same way. R is very particular in the sense that it's an array language. There are other array languages, but R is definitely one of the most popular ones. So everything is an array. If you take a look at an R string, it's just a length one string array. If you take a look at, I don't know, an integer like one in R is not just one, it's an array of length one of a single integer. So that gives it some very cool aspects when it comes to data processing because we can vectorize, right? This concept of vectorization is really cool in R. But that comes to the negative that when we try to send data to perhaps an API, it's like, hey, this is not an integer, this is an array, right? Or maybe it's expecting an array and some sort of function that we do to try to mitigate that does the opposite thing. So I have here an example of the OpenAI API. And one of the particular ways of calling the API is having file search. So file search basically goes and does, in a vector store, it goes and does a search. But the particularity is that, for example, the vector store ID's little field inside the tools field, it's kind of weird to say, but yeah, that's basically what it is. The vector store ID's field is expected to be a string array. So if we set a single string in the way that we would typically do in R, what this would do is, I'm gonna run this. If we turn this into JSON, we can see that everything's gonna be an array. We see that model GPT 4.1 is not a string that says model GPT 4.1. It's an array that says, that has a single value that's GPT 4.1 in it. So if we try to send this as it is to OpenAI, it's gonna tell us, hey, this is bad. I was expecting a string in model. You gave me an array. This won't work. What you typically do is that you put in the little auto box equals true argument. And what this will do is that it will, everything that's a length one array, it will turn into its atomic type. So if it finds a length one string array, it's going to turn it into a single string. Or if it finds a length one integer, it's going to turn it into a single integer.
Why don't you show it, Andres?
I'm going to
Because
show it. Thank you,
this
Franz,
is the
for
magic
reminding
trick.
me.
Yeah, this is the magic trick I was talking about. When I started doing this, this was very confusing. The good part is that I learned a lot about how vectors work in R. But you can see here that model now is different to what, well, everything now is unboxed. That's the thing.
That's kind of the joke, right?
Yeah, that's the
But the negative thing is that we wanted vector store
yeah,
IDs to actually
exactly.
be an array, right? Vector store IDs is now a single string. So now OpenAI, if we send it again, it's gonna complain again. It's like, hey, vector store IDs, I expected an array of strings. You gave me a single string. So yeah, we're kind of stuck between a rock and a hard place because it's like, what are we supposed to do? What you would typically do is either go and manipulate the data in some sort of way that the serialization does exactly what you want it to do, perhaps using unboxes. So what you would probably need to do is go ahead and do unbox over every single of the ones you want to unbox and don't unbox the ones you don't want to unbox. But that's so tedious. And if you have an array of, I don't know, 100 of these, you're gonna have to do some sort of apply or go through every single one of those and do the unboxes where you need them to, and don't do it where it's gonna become. It's not gonna be a fun time. Is basically what's going to happen. So to try to solve this type of problems, we developed what's called structr. So what structr allows us to do, similar to what a Pydantic does on the Python side of things, is define a data contract of sorts that we have like, okay, this is going to be the structure of whatever is going to be coming in or going out. It
Mhm.
has certain data types. Some of them are required by default, everything's required, but some of them are going to be optional. And how does that look? Is it a vector? Is it not a vector? Is it a length one? Is it not? That's what we define right here. So if you take a look here at the code that I'm showing, we have a structure. And inside the structure, we define the different fields. So here, model is a string, temperature is a double, max tokens is an integer, right? We don't want 100.1 tokens, we want 100 tokens. we want log props, but log props is optional, right? We don't need to send it. So we should make it explicit that it's optional. Same for top log props. This is not required by the OpenAI API by default, right? It's optional, so we need to define it as optional. Messages is a vector of a structure that contains two fields, role and content, both of them being strings. And what this allows us to do is that it gives us a contract that we can validate against when we're serializing or when we are deserializing JSON. So right here, I define the structure both for the request and for the response of the API.
And the
So
cool
here
thing, the
go
cool
ahead.
thing here, Andres, you mentioned the word contract. So what we usually do in the projects we develop in Expantia is that we make a point of getting the agreement between all the parties when there is data going in and out of a series of systems, to have contracts, for instance, with APIs, microservices contracts that specifically state what is going to be sent and what is going to be received. And to be able to translate those agreements directly into code that will validate whether we meet the requirements that we agreed with the other parties is great, because our code will fail when we're not meeting the requirements. We don't need to wait until we make the actual call. And this makes it much easier to catch any errors in time before they're actually interacting with any of the systems of other parties.
Absolutely. And again, when most of the time in data, we're working with really loosely typed languages.
Yep.
And this is especially important. And we're going to see that later because we're probably going to need like a bunch of asserts in our code to validate all of this. But yeah, let's say we define our request structure, but we can also define our response structure, right? We send JSON, it gives us back JSON. So in this case, we define a nested structure that defines exactly how we want our data. We also have the ability to ignore data validation. So here in log props, I didn't feel like writing the code to validate that, so I just put in an s_any_map, which is basically just an R list, right? It's a key value pair of anything to anything. So in this case, I just set an s_any_map to kind of do it, and it's optional. If we don't send log props as true, it's not going to send us back log props. So I need to tell it, hey, even though this can be a map of any type, please ignore it if it's not present. And yeah, that's basically what we do. We can now get into the fun part. We define here a body, for example. I already have my API key loaded in memory. If I send a post request, this should just work, right? It didn't give us any errors. Yeah, look, now couldn't parse the JSON, and it gives us a really bad message. It just told
Yeah.
me, hey, couldn't parse the JSON. This likely means you aren't using your HTTP library correctly. But that's not really a very good message to respond with. But if we had our contract, basically how the documentation would tell us to, we would receive an error immediately once we got
But
that. So that right there.
one of the really cool things is that the structure of your data as it is going to be sent out is decoupled from your actual data. So the cool thing here is that what Andres is showing is that he can change the structure of the post that he will do, the data that will be sent out in the body, but he hasn't touched the data at all. And here we have a little example data, but imagine if you have a lot of data that is behind it. This is a really cool trick.
Now, if let's say we got our response from the API, right? So we have here our list. This shouldn't really be rest parsed because it's not parsed yet. But we can see here, we received the data. And we don't really know. I mean, I trust OpenAI that sends the right data. But if we are just starting to integrate a couple systems, we don't really know if the data is correct. Or we don't know what the nuance in the data, if that's perhaps how we would want to call it, what the nuance is. Maybe some fields return sometimes, maybe they don't. In what format? How do they come? So if I now parse this JSON, right, I'm gonna get expected string. Oh wait, what do you mean expected string? Right, here in the response body, I said ID is a string. But OpenAI didn't send a string, it sent an integer. That's what the documentation says. I'm doing a wrong assumption. If I switch this now to integer and I run this, I should be able to now parse this JSON. Where am I expecting a string correctly? Because ID, I believe is, no, ID is a string. Where am I expecting index is perhaps,
Index.
yeah, I think index is the one that, no, because it's expecting signed. Yep, it's it right there. If I do here, now if I parse it, now it expects a string somewhere, which I think it is this one. So let me go back to integer. I believe this. I would have to take a look back at the documentation. I don't remember exactly
I
what
wasn't
is the
paying
field then.
attention. It worked 5 minutes
Yep.
ago.
Yeah, it worked 5 minutes ago and now it's not. I don't know what we changed. Created? No, created is an integer. I am very sure.
ID is an
ID.
integer
Oh, we can
also.
take a look at the documentation.
Yep.
Let's go. OpenAI API spec. Here's the API reference. Right, so index is an integer. So index right here should be an integer.
It
This
is.
should be fine from
It should
my,
be.
yeah, there shouldn't be any issues with this. Oh, there you
There we
go.
are. Yep.
There we are. Yeah, we can cut that part. Okay,
But
so
again, it's to the point. I mean, the
yeah, it's to
fact
the
that we are
point.
able to do this from just documentation without having to call the API again is really worth the effort. I've spent so many hours trying to debug these things without having tools like this.
And we still need to improve the error messages in the package.
Absolutely.
That's an absolutely important part to work on. But the point is, it's it does the validation as we want it to. And as a final example, dates is one of those that is weird, right? So typically, if you're working with an API that perhaps works in a non-standard date format, or maybe it just works normally with the date format, right? If we do JSON light here in the console, JSON light from JSON, and we pass it a 2020 or 101. And of course, I need to give it like the single quotes around it so that it takes it as JSON. I'm not sure this takes it as a date. No, it takes it as a character, right?
Yep.
But if we know for a fact that it has to be a valid date, we would want to probably validate that at the moment we read the JSON. So we can absolutely define a structure that has a date type. So here the as date, we can tell it a format. So now what it's going to do is that whenever it reads the JSON, it's going to try to parse a date according to that format as it's reading the JSON. So we defined here weird date. I don't know why I called it weird date, but weird date it is. That has this format of year/month dash day. And
Oh,
if we have our
that's
JSON
weird.
string, it is weird a little bit. I've seen worse. Once we try to read it, right, it actually reads as a date. So if we take this and pipe it into class, we're gonna see that it prints out date because this is a date. The contract that we define up here tells us this is a date. It has to be a valid date. It comes in as a date. And if I were to send in an invalid format like 2023 dash instead of slash in one of them, this is gonna give me an error.
This is so cool,
Input contains
right?
invalid characters. It's a date, and we defined a contract. The JSON is not. It doesn't go with what we wanted to. So
Because
yeah, we have this cool example. Go ahead.
so yes, it is weird, but there are weird examples, and especially when we're working within
Legacy systems.
exactly organizations with legacy systems, you can see very weird things. And to be able to have this level of control is unbelievably powerful. It helps a lot.
If we were to try to send, for example, now a date, now that we defined this y slash,
Uh-huh.
typically if we take any date in R, so if I have like here this R dates vector, and I try to use a library like JSON Lite to JSON, I mean
Maybe
we
send
have,
today.
yeah, oh, we can send sys.date, for
Yeah.
example, right? It's date with capital D, right? If I do this, it's gonna give me the format in what in year, month, date. We can have some level of customization with this. We do have, I think, date, and we can set date to either ISO 8601 or epoch. But we have only those two options. Again, if we're working with legacy systems, maybe it doesn't follow ISO. Maybe it follows whatever they came up with in the 80s. I don't know. So with serialized JSON from structure, we can actually enforce that contract when writing JSON as well. So if we send here our sys.date to take today as a weird date, it's actually going to give us the 2025/04-24. We can put in here a couple more slashes just to make it a little bit weirder. It's going to enforce that both when reading JSON or when writing the JSON. And that's basically an overview of this little package that we're building. It's meant to help anyone that's working with APIs, either as a client or maybe even as a server, right? Let's say you have a Plumber API and you need to receive user input. You may want to validate that input. If you're writing something to a database from user input, please do validate it. So yeah, that's basically an overview of structure. I don't know, Frans, if you have anything else to say.
No, I think this was great. Thank you so much, Andres. And if there's any questions, by all means, let us know through whichever channel you're watching this video.
Amazing.
Bye. Take care.
Bye-bye.